manufacturing process. So these are all the ways that you can do the process optimization. First one is by elimination technique. You can look for reduction. You can modify the process. You can also look for some increase of for some of the features. You can look for some creation. You can look for some substitution. You can also look for rearrangement. You can also look for elimination. You can also look for combination, and you can also look for adaptation. So these are all the different ways that you can use to optimize the manufacturing process in order to increase the productivity for your manufacturing plant. This is a job methodology, value methodology plan. So basically you have 3 stages. First stage is pre-workshop stage, and second one is workshop stage, and the third one is the post-workshop stage. So in pre-workshop stage, you select which project you are going to select, and then you collect the preliminary data, you form the team, then you go for a workshop stage where you have very important phases called 6 phases. First phase is information phase, where you are going to collect the information about the manufacturing process, and you are also going to collect the function of the process. So function is the heart of value engineering, value methodology. We are going to see with one example of this function, and next one is nothing but the creativity phase, where we are going to create ideas through functions, and here we come up with a lot of innovation, lot of invention, and then we are going to evaluate the ideas which have been invented or which have been created here. So when the invented idea is been implemented through evaluation in the case of a development phase, then it becomes innovation. So innovation is the one where you are going to implement the ideas which you have created in the creativity phase, and finally you are going to present it to your management, and then you are going to implement it. So this is the function analysis basically. So function analysis can be applied to a product, and also it can be applied to a process. So here you are going to break down and the manufacturing process into a number of assemblies. And here, when you are identifying the function for your assembly, the key question that you need to ask is what the process is all about. What is the main objective of that particular assembly? You need to identify the need of the particular manufacturing stage or a process. Then you need to identify the specification functional with respect to function aspects. Then you also need to validate it, and again here when it comes to validation, it's not only the function specification here comes, and suppose if you do modification like changing the process from X to Y or Y to Z by analyzing the problem statement, then what you can do is you can also validate those things considering the optimization for your process and the process design what you have done. And here the very important thing is you have to analyze the function considering the technical aspects, the manufacturing feasibility aspects, and also you should consider the risk analysis as well. So as I said, the function is the heart of value engineering. So you have one technique called FAST technique, which is nothing but function analysis systematic technique diagram. So here what you do is you are going to take either one of the manufacturing process, or even you can take your complete assembly process. With the help of this FAST diagram, what you will come to know is you will come to understand what is the various functions the particular assembly is going to do, or a particular machine or process is going to do. So here for an example, I have taken a overmolded stamping process. So the basic function of a overmolding stamping process is to overmold stamp. Okay, so here now I'm going to apply the how logic, why logic. How I can overmold my stamping process by injecting the plastic, by generating the stamping. So again I am asking the question how I can inject plastic by liquefying the material, by heating the material, and I can also inject plastic by generating pressure, by creating friction, by converting the energy, and how I can convert energy by receiving power. I can also overmold stamp by generating stamping, by forming the material, by applying pressure. So now I am going to apply Y logic. So why I need to receive power or supply material for a manufacturing process of overmolding stamping process. So I need to receive power. I need to give power to convert energy, to apply pressure, to form material, to generate stamping in order to get the overmolding. Finally, the bond assembly. Okay, so these are all the how logic, Y logic, and you need to identify what is the basic function, what are all the functions which follows the basic function, which is nothing but a secondary function. You need to identify what is the objective of your process or a machine or a assembly sequence. So here the project objective or a design function is to verify the dimensions of the overmolding stamping process. You should maintain the tooling, you should control the process, you should also maintain durability, and you have order time function, which is maintaining the appearance, preventing the injury, ensuring reliability, and reducing the scrap. So you have two scope line, one is left scope line, another one is right scope line. When you move from left to right, you follow how logic. When you move from right to left, you follow Y logic. So what is the advantage of this fast diagram? So this fast diagram will help us to identify what are all the basic functions, what are all the required secondary functions, and then the design functions, one-time function, order time functions. So by analyzing all these functions, we can go for a next phase called a creativity phase, where we can create ideas considering the functions. Okay, so whatever the 3M, you have created a lot of ideas. Okay, see here the uniqueness here lies by analyzing the function here in the case of value innovation. So as I said, you are going towards innovation through invention. So invention is nothing but creating new ideas, and that is possible by various means. But again, here you can use this technique as one of the way where you can create ideas using functions. So how you can create ideas using function here is, so you have to look at the individual functions and you have to look at the ideas. You have to generate ideas through functions. And there are various ways this can be generated by using the logic, as I said, how logic, Y logic, and you have uh, getting system as well here. You have a AND function. So here you follow and you also have OR function, which means this function can be achieved. This function can be achieved either by this or by this. But here, overmolding stamping is going to happen by both injecting the plastic and also by generating stamping. And these are all the tools that you can use for your process optimization. As I said, this function is the heart of value engineering, and you can use this tool for your optimization of your process. And 3M, and as you are already doing this lean manufacturing. And you can also look for Six Sigma. You can use some of the quality tools like quality function deployment. And this is also a unique tool that you can try using it in your process, which is nothing but the TRIS, theory of inventive principle. It is having 40 principles. Even if you want to do some optimization, or if you want to increase the productivity, what you can do is you can use this tool where you can also get some solution using this tool. Say for example, if you want to increase your productivity, what happens? You can also go for automation, and then there are various ways. When you are going for automation, what happens is there can be some of the during the initial stage there can be some of the um, drawback, or some of the issues might come, and how you can resolve those issues. Okay, with the help of this tool you can try optimizing the process, which will help to increase not only the productivity but also the overall process improvement that you can use with the help of the TRIS process basically. And the next one is DFMA tool is also you can use for your optimization. And you can also look for some of the creativity tools where you have a lot of creativity tools like brainstorming, brainwriting, 635 technique. You can go for a nominal group technique. You can go for a Gordon technique. So there are a lot of ways where you can create ideas, and this is also one of the tools where you can use for your process optimization. Here the key concept here is when you're going for a value engineering, as I said, it's going to be a systematic process and it's going to be an organized approach. Here you're going to provide the necessary functions in a project at a lower cost. So this is very important. And here you can go for a material substitution or a method substitution where you're looking for a less expensive alternatives. So this alternative is through a function and you're not going to sacrifice any of the functions. So functions can be, you need to analyze all the necessary function again. So when it comes to product, it's product engineering where you're going to look for innovation considering the design, development and testing, and then you finally go for a deployment of the product. And when it comes to process engineering, it is an engineering that focuses on the design and also optimization, which involves biological and also the chemical process here. And put together product engineering plus process engineering, that is where it comes to manufacturing. So here it's a great catch when it comes to the optimization of the manufacturing process. And when it comes to process engineering, you look for process development and also process innovation. And process development is nothing but it's the one which consists of the process leading to the product starting from the initial idea to the sale of the final product basically. And here when it comes to the innovation of the process, it is nothing but the one which we are going to apply for a manufacturing process or a goods or a service that can be new or significantly you can also look for your existing manufacturing line or assembly as well. And innovation is what it is going to separate a high performing organization from the rest of the pack. And the greatest difference between invention and innovation is you are going to implement the ideas what you are going to create, and that is where this value engineering or value innovation comes into picture for your manufacturing process. These are all the importance of value innovation. This helps for your growth of your company. It helps to help you to stand out uniqueness and with respect to the competition, and you can also be able to meet the need of your customer. And whatever the needs, it can be the productivity improvement or quality improvement or the defects free product. So you can apply this technique to all various means in order to meet what the customer really wants. And this also helps you to solve the problems. So you can create ideas which will help you to solve the problems. And problems here is through functions. So function is nothing but what is the main purpose or intent of the particular activity or a particular stage of assembly or particular process of assembly basically. And here this will also help you to look for changing, adapt to your change. And again, it is also helps for the maximization of the profit. Considering the globalization, you need to face the competition for which this value innovation will be very much useful. And you can also apply this for evolving the workplace dynamics. So these are all the 10 distinct dimensions of value innovations. So first one is going to be the strategy, second one is network, resources, and you are going to have the process system, process performance, and this, as I said, this can be applied for a product as well. So product system, product performance, service, channel, brand, and customer and clients. So through these 10 distinct dimensions, you can achieve the value innovations basically. Again, when it comes to the manufacturing process optimization, you need to have a manufacturing capabilities which will increase the need for a small and high-skilled workforces and integrated networks, which can be applied for a smaller, specialized and flexible plants. And this also helps for bringing innovations to manufacturing capability, exploiting the new technologies in order to improve the performance and bringing a more profitable and new products to the market. And these are all the different innovations that you can look with respect to the manufacturing aspects, considering the impact, extent, the radicalism, and timing. and you have process innovation. You also you can also look for some of the breakthrough innovation through functions again. You can also look for some sustaining innovation, disruptive innovation, overturning the innovation as well. And but again, this you need to look at the innovation where that can be used as more for your productive improvement and defects free and incremental innovations. And you also have a product innovation, technological innovation, and breakthrough techno commercial and techno economic innovation, and breakthrough permanent innovation, hack innovation, and open innovations. So you need to look for all these things, and you need to implement it. And again, the innovation, it should not be so considering the other innovation. So this disruptive innovation is it's not highly recommended because this is something the one which will overturn the innovation basically. And again, we need to always look for a sustainable and breakthrough innovation again. So first, key things is you need to understand the manufacturing process, and this is possible with the help of 6 degree of pedigree of process. So first one is going to be the precision, where you can understand the level and sustainability, complexity, then throughput speed. What is the speed that you can run the process without compromise on the quality, and then the current cost of your process. And you should also look for compatibility with advanced technology, and where you can also look for some of the technological benchmark. And you should also look for some of the scalability, whether your process can still be optimized for higher volume. So this is where many of challenges comes. And you should also look for the pace of development. How much time will it be needed to gain the pace of development? So these are all the 6 uh, pedigree of process in order to determine the manufacturing process. When it comes to the innovations, again, you need to look for the manufacturing strategy. You should look for creating a new process, and you should also look for some building a new manufacturing equipments, like designing, developing a new manufacturing machines, manufacturing system integration, integrating the process, and this is main material machines, what you call. And you should also look for sharing and sourcing the networks. And again, when it comes to the network operation performance, so here what you do is you need to look at performing better through detailed audits here. And these are all the different manufacturing innovations types basically. So totally we have 5 types. The research says that only 2.5 percentage of the manufacturing engineers.
Arjun sir, sorry to interrupt you. How long will you take? How much more time you would need it?
Another maybe 5 minutes.
Yes, sir. Thank you, sir.
2.5 percentage are the risk takers, and the remaining only out of 100, only 2.5 are risk takers. They are nothing but the innovators. And the remain out of 100, 13.5 percentage are yearly adopters, where they are just an opinion leaders, and 34 percentage are yearly majority, and 34 are late majority, and 16 percentage are laggards. And, these are some of the common challenges that you have in implementing the value engineering for your process: lack of awareness, lack of resource. So as I said, the value is nothing but function by resource. You need to understand your resource basically with respect to the resource here, the manpower, the cost, resource, energy, the time, infrastructure. So all this comes here, and lack of follow through, and then lack of proper customer feedback system. But when you have to start implementing the value engineering, so you can start at any stage, any process, anytime, any day, but only with the proper strategy you need to have, and the knowledge and then the guidance. How can you get the VAVE right? By understanding and analyzing the functions. This is very much important. So function is nothing but what is the main purpose, what is the main intent, what does it do, what must it do, what else it will do. And then the features you need to understand, you need to select a great VAVE leader, value analysis, value engineering leader. You should acquire the multidisciplinary support, as I said initially. You should generate a lot of ideas through functions again. You need to execute it. These are fundamental questions with respect to the thing manufacturers will ask themselves. Where are we now? Where we need to go? And what balance of innovation that we need to have? Can we attract and keep and the innovation talent? And are we going to collaborate with the outside of our organization? How we are going to know the success? What we are going to see it? This product innovation is the one which is visible to your customer, and a change in process is typically seen inside your company, and this has been valued internally. And product innovation has been seen to the people, to the customer. And these are a few examples for value innovation in manufacturing. Started in 1901 by Rams and E. Walls. He used the assembly line which was been patented or manufactured. And in 1913, Henry Ford invention of world's first moving assembly line. In 1926, unified assembly line by Big Motor Company. In 1948, Toyota Motor Corporation developed a lean manufacturing. And in 1961, the first industrial robot began working in GM assembly line. These are all some of the innovation trends with respect to the manufacturing, virtual manufacturing, 3D printing, industrial robotics, and even this is also very important, exoskeleton for your workers. So these are some of the manufacturing innovation trends happening. Sensors, and these are 5 technological applications impacting the value to the manufacturing innovation basically. So you can look for the 3D printing, additive manufacturing, advanced material, cloud computing, IoT, and then the nanotechnology. So these are all the 5 technological applications impacting the manufacturing innovation. The conclusion here is what next? So we live in an era of constant transformation. So ability to be flexible and agile is one of the quality for success. And so you need to apply this innovation, which is very much important for you to improve the productivity, and you need to look for some of the breakthrough ideas for increasing the customer demand. And here also you need to look at some of the advanced technologies that you can apply it for your numerous application of manufacturing. Successful VAVE campaigns take leadership, support, ideas, and execution. And here it's not just ideas alone, you're going to execute it. And ultimately the perseverance, because perseverance is very much important, because the time taken to implement the ideas needs a lot of time and a lot of validation. That's where your perseverance comes into picture. Finally, you are going to look for a success for your organization. Thanks a lot for this opportunity. And you should always have a value, which should be the vision, and you should always have a FCWA, which is nothing function, cost, worth analysis. So you should always look at the function, cost, and function worth. That should be your mission. And always look at function is the foundation, and the diagram what I shown, that should be the model for you, which can be applied to any of your manufacturing process. Thanks a lot once again, and this is my contact details. I can be contacted at p.arjunraj@gmail.com, and this is my contact number 877-898-3428. Thank you. Thanks a lot once again.
Thank you very much, sir. A very enlightening thing, and the way it is taken forward. We talk about analysis, engineering, and methodology. The way it was described, the way it started with these 3 functional words, and the positivity of flowing through this presentation and trying to understand the carryaways of this particular value words, the functional methodologies of taking it through, and how to actually run through this particular process of Either we call it a VAV or VM. But why don't we really understand this? And how do we really understand? Mr. Raj has taken us through certain presentations in this modus of around 30 minutes. He has tried his best because this really takes a long time and its depth of knowledge is very high. Time is something that we cannot control, due to which I thank Mr. Raj trying to summarize the big value project, big value knowledge into a short form and trying to compress it to meet the needs of the participants and making them much better in the level of understanding. I'm sure that there has surely been a value add on whatever knowledge we all did carry. And on behalf of TPM Club India, CII, Institute of Quality, I thank Mr. P.Arjunraj for giving us this presentation. Thank you, sir.